Hi, welcome again. And now we will continue our learning on gas pressure transient analysis or gas well testing analysis or gas well deliverability analysis. And in previous videos, we have discussed the analysis using theoretical method. And in this video, we will solve or we will calculate a gas well deliverability using empirical method, or it is also well known by the term C&n method. All right, so as usual, we have our gas well test data table here. We have several columns, the period, and then the duration in hours, the choke size opening if you have the data, and then gas flow rate, static bottom hole pressure in PSIG and PSIA, and flowing bottom hole pressure, and also the column for this calculation. And in this video, we get the data in terms of pressure drawdown. So we have static bottom hole pressure data, and we have the drawdown pressure. We will calculate the flowing bottom hole pressure. All right. So first, I want to refill the duration here. So we perform multi-rate well tests for a specific or a particular gas well. Our gas well has a tubing with internal diameter of, for example, 2.441 inch. And we know the depth of our well. It extends down to 6,000 feet. And then we perform gas well testing to obtain or to know the deliverability analysis. And we will solve, we will analyze, we will evaluate the deliverability using empirical method or C&n method or Rowlin and Shildart method. So we have several or 4 flowing periods, and each period we also have shut-in period. So the first one, we start with static bottom hole pressure measurement, and we know that the bottom hole pressure is 7,121 psia. And then we do the flowing period, the first flowing period for 9 hours, followed by shut-in of 9 hours. So we actually do modified isochronal tests. Okay. So in the note section, we perform modified isochronal test with 3 isochronal steps and followed by stabilization or PSS pseudo steady state flow, something like this. All right. So by isochronal steps, I mean flowing period followed by shut-in period. So here, isochronal steps, flowing plus shut-in, and followed by stabilization or PSS pseudo steady state flow period. All right, so that's the test. So the first one is 9 hours flowing followed by 9 hours shut-in. For example, we don't know the choke size, but we know the flow rate. This one. I will refill the data. Okay, so we know the data, the first, second, and third. And for the fourth period, we do the stabilization, all right, or pseudo steady state flow period for 1 hour 20, 1 hour 20 hours, 120 hours for 5 days. Okay, we need to flow our well for this long to achieve or to obtain pseudo steady state flow regime. And that's very, very important to know our gas well deliverability. So you can also call this one transient flow, transient, and then this one is PSS, pseudo steady state flow. Okay, and yeah, we know the flow rate, and then I will refill the static bottom hole pressure. Actually, know the PSIA. So the first one is 7,101 PSIA, the static bottom hole pressure after 9 hours of shut-in, and then 7,085 PSIA after 9 hours of shut-in for the second period, and then for the third period, 7,070 PSIA. And for the final one, we actually don't perform shut-in after PSS flow of 120 hours, but we can input the initial static bottom hole pressure data that we obtain before the well test, which is 7,121. So I will put that data here. All right. And then in this test, we also know the drawdown pressure. So the first one, 905 PSIA, the drawdown pressure. And then the second one, 1,156, and then 1,802. And the last one, the stabilization period, 2050. So if we know the PWS, static bottom hole pressure, and the drawdown pressure, we can calculate the flowing bottom hole pressure, all right, by simply this one minus the drawdown. So it's very easy, okay? And then, yeah. So you can calculate the PSIG from PSIA, right? By using this formula, very simple one for PWS and PWF. And for the last column, it's very easy, PWS squared minus PWF squared. We use the PSIA here, okay? So we complete this table and we go to the second step is plotting the PWS squared minus PWF squared versus the flow rate on a log-log plot. And we already did that.